Hello students, welcome back to Narayana Digital Classes. Today we will be solving the assignment number 37 on the topic atomic structure. Let's move on to the assignment. Here the question, the de Broglie wavelength lambda equal to, right? So de Broglie find the wavelength, that is lambda. So that lambda is equal to h by mv, where h equal to Planck constant, m equal to mass of electron, and v equal to velocity of electron. So the correct option is third option. Clear? Let's move on to the next question. Here the question, in lambda equal to h by mv, so h is here. So what is the formula, this one, lambda equal to h by mv, that is de Broglie wavelength, where h equal to Planck constant. So the value h equal to Planck constant. So the value for the Planck constant 6.625 into 10 power minus 27 erg second. Right? So which is Planck constant. So h equal to Planck constant. So the correct option is fourth option. Clear? Let's move on to the next question. The question is, the number of revolutions of an electron per second is an orbit equal to. So here we need to find the formula for the number of revolution of an electron, that is velocity of an electron by circumferences, right? So the correct option is first option. So the number of revolution of an electron which is per second is equal to velocity of an electron by circumference of that particular orbit. Clear? Let's move on to the next question. Here the question is, the relation between the kinetic energy and wavelength of moving particle is lambda. Right? We know that lambda is a de Broglie wavelength, that is h by mv. So we can write it as h by p. So since p is the momentum, so that is p equal to m into v. Right? So we need to find the relation between the kinetic energy and wavelength. So we know the wavelength formula h by p. Then what about the kinetic energy? So then kinetic energy K equal to P square by 2m. Then P square equal to 2m into kinetic energy. Then P equal to root over 2m into kinetic energy. Right? Now substitute these momentum value in this formula. Now we will get the relation between the kinetic energy and the wavelength. Then wavelength lambda equal to h by root over 2m into kinetic energy. So this is the relation between kinetic energy and the wavelength. So the correct option is first option. Clear? Let's move on to the next question. Here the question, the circumferences of the orbit in 2 pi r equal to. The circumference of orbit is 2 pi r equal to, that is always equal to the n lambda. So the correct option is third option. So 2 pi r equal to n lambda. Clear? With this, I come to the end of the session. Thank you very much.